Jean, and we are so excited to finally start this journey with you all. We've been wanting to do this for a while, and today is the day. On this channel, we'll be breaking down math concepts step by step, solving problem math together, and it's even exploring real-life applications of math. From basic arithmetic to advanced topics, I've got you covered. So if you're ready to boost your math skills, make sure to like, subscribe, and hit the notification bell so you never miss a lesson. Alright, let's dive into this lesson. Have you ever wondered how we can represent complex functions using simpler infinite sums? Today, we'll explore the power series and learn how to determine the radius, center, and interval of convergence using the ratio test.
Let's have some key definitions. The power series is an infinite sum of the form summation of c sub n times the quantity of x minus a raised to n, where c sub n are coefficient, x is a variable, a is constant, and n ranges from 0 to infinity. Then, we have the radius of convergence. The radius of convergence is any number such that the power series may converge from the absolute value of x minus a is less than r and diverge from the absolute value of x minus a are greater than r. Then the power series may not converge to the absolute value of x minus a is equal to r. Then we have now the center of convergence. The center of convergence refers to the point around in which the power series is centered. It is denoted as a in the series. The absolute value of x minus a is raised to n. Then finally, we have the interval of convergence. The interval of convergence is the set of all the values in which the power series converge.
We will use the ratio test. The ratio test for convergence is based on calculating the limit of the absolute ratio of consecutive terms in the series of r is equal to limit as n goes to infinity of the absolute value of an plus 1 over an. Here, an represents the n term in a series and an plus 1 is the following term. If the limit is less than 1, the series converges absolutely. If it's greater than 1, it diverges. If it equals 1, the test is inconclusive and we need to check the endpoint. Conditions for finding radius of convergence and interval of convergence in a power series. Case number 1. Limit as n goes to infinity, the absolute value of an plus 1 over an is equal to 0. When the ratio test gives a limit of 0, the power series converges for all values of x. Thus, the radius of convergence is infinity and the interval of convergence is negative infinity and infinity. Case number 2. Limit as n goes to infinity, the absolute value of an plus 1 over an is equal to infinity. When the ratio test gives the limit of infinity, the power series converges only at the center. Thus, the radius of convergence is 0 and the interval of convergence is c. Then the last case, case 3, limit as n goes to infinity, the absolute value of an plus 1 over an is equal to n. When the ratio test gives a finite non-zero limit in terms of x, the power series converges only within specific interval. Thus, radius of convergence can determine using inequality x minus c less than r and the interval of convergence c minus r and c plus r, where endpoints convergence must be checked separately.
Are you ready? Now, get your paper and follow me in solving. Let's work through an example number 1. Consider the power series. We have the summation of n factorial times the quantity of x minus 1 raised to n, where n is equal to 0 to infinity. Now, we will apply the ratio test. We have the limit of n approaches to infinity of an absolute value a sub n plus 1 over a sub n. So our given will be our a sub n. And to get our a sub n plus 1, we just have to put plus 1 in every n term. So we have the n plus 1 factorial times the quantity of x minus 1 raised to n plus 1. All over our a sub n, we just have to copy our given a sub n. We have n factorial times the quantity of x minus 1 raised to n. So at this point, we can now expand our dividend. So we have n plus 1 times the n factorial times the quantity of x minus 1 raised to n times the x minus 1 raised to 1. So we don't have to put 1 as our exponent. All over, just copy our divisor n factorial times the quantity of x minus 1 raised to n. Oh, sorry, I forgot to put, but it is all absolute value. So now we can now cancel x minus 1 raised to n since they are both in divisor and dividend and also n factorial. So now the equation will just remain x minus 1 and n plus 1. So we have the absolute value of n plus 1 times the absolute value of x minus 1. And now we can now get the limit of n approaches to infinity of our absolute value n plus 1 times the absolute value of x minus 1. We just have to substitute infinity in our n. We have the absolute value of infinity plus 1 times the absolute value of x minus 1. So now infinity plus 1 is also infinity times the absolute value of x minus 1. Infinity times the any values of x is just equal to infinity. So as you can see, we have the limit of infinity. So as a case 2, the limit of n approaches to infinity of a sub n plus 1 over a sub n. If it is equal to infinity, then our radius is 0 and the interval will be c, which is our center. So to get our center, we have to equate our x minus 1 into equal to 0. So now our x is equal to 0 plus 1. So the value of x will be 1, which is our center. And now we have the center, which is equal to 1, and the radius, which is equal to 0, and our interval is c, which is 1. Now, did you get how to get the center, radius, and interval of a power series? So now let's proceed in our example number 2. So our power series given the summation of x raised to 2n over n factorial times 2 raised to n, where n is equal to 0 to infinity. Again, we will now apply the ratio test. We have the limit of n approaches to infinity of the absolute value of a sub n plus 1 over a sub n. So again, this will be our a sub n, which is our given. And for our a sub n plus 1, we will just put plus 1 in every n term. So we have the absolute value of x raised to 2n plus 1 over n plus 1 factorial times 2 raised to n plus 1. And that will be our dividend, which is our a sub n plus 1. And for our divisor, we just have to copy our a sub n, which is our given. We have x raised to 2n over n factorial times 2 raised to n. Now, this is the absolute equation. After that, we can now expand our dividend. So we have to multiply 2 times n plus 1. So we can have x raised to 2n times x squared over n plus 1 times n factorial times 2 raised to n plus 2 raised to 1. And to multiply it, we have to get the reciprocal of our divisor. So the reciprocal of our divisor will be n factorial times 2 raised to n over x raised to 2n. Now we can now cancel n factorial and 2 raised to n both, since they are both in dividend and divisor, and also x raised to 2n. And now, it will just remain x raised to 2 and n plus 1 and 2 raised to 1. So now, let's rewrite the remaining equation. We have the absolute value of x squared over n plus 1 times 2. Now, we can now simplify n plus 1 times 2. So, we have the 1 over 2n plus 2 times the absolute value of x squared. After that, we can now get the limit of n approaches of infinity of our absolute value. We have the 1 over 2 times the infinity plus 2 times the absolute value of x squared. So now we have 1 over infinity times the absolute value of x squared. 1 over infinity is equal to 0 times the absolute value of x squared for any values of x is just equal to 0. So now what will be the value of our radius? So remember, from our case 1, we have the limit of n approaches to infinity of the absolute value a sub n plus 1 over a sub n if it is equal to 0. Thus, the radius will be infinity and the interval will be negative infinity and infinity. So now our radius is infinity. And for our interval, we have the negative infinity to infinity. And lastly, our center is just 0. If you have any more questions, just comment down below and we will answer your questions in another video presentation.
To summarize, we've learned how to find the radius, center, interval of convergence of a power series using ratio test. Remember the key step. Apply the ratio test, find the radius, find the center, and check the endpoints. Here are a few practice problems to try. I hope this tutorial helped you to understand the power series, radius, center, and interval of convergence better. Remember, math is all about practice and patience.
So keep working on those problems. If you find this helpful, don't forget to like, subscribe, and click the notification bell so you never miss a new lesson. Also, let me know in the comments what topic you'd like to cover next. Thanks for watching. I'll see you in the next vlog.